Solving for equations with trig substitutions can get a little bit trickier. The first one that's listed here, there's only a tangent x in it, so all you're going to do is take the square root of both sides, and you're going to be left with plus or minus 1. Now, there are a lot of cases with plus or minus 1. If you think about the reference angle, that's going to equal pi over 4. Again, you can use the table or using reference angles, or you can use the unit circle. But I know the reference angle is pi over 4, but you have all of those quadrants that are going to work with the positive or negative tangent. Therefore, the reference angle is going to create all of those angles. I'll just list them below. Pi over 4, 3 pi over 4, by subtracting it from pi, adding it to pi, 5 pi over 4, and subtracting it from 2 pi, 7 pi over 4. Now, each of those go up by 2 pi over 4, so the way that you can list it to find all values of x is going to be x is equal to pi over 4 plus 2 pi over 4. Okay, and that could be negative or positives either direction. One way to write that. Looking at this one, I can't do much with these two, so I have to separate that sine squared x into cosine squared, and therefore I'm going to use the Pythagorean identity to do that. And now I want to expand this side and eventually try to factor it. So 2 minus 2 cosine squared x minus cosine x minus 1 equals 0. Oh, let's see. Multiplying through by a negative and combining those terms. So it's going to be 2 cosine squared x plus cosine x, and that's going to give you 1, so it's a minus 1 when you multiply by negative 1. In this case, I'm going to try to factor 2 cosine x and cosine x. This is only can be plus or minus 1. So I'm going to see that this is plus 1, this is minus 1, and when I check the middle terms, minus cosine x plus 2 cosine x gives you a positive cosine x. Therefore, my cosine x can equal 1/2, or cosine x can equal negative 1. Now, the easiest case is that negative 1, so again, I like to draw it and figure out where it equals negative 1, and that's going to be at pi, or you can use the unit circle. So x is equal to pi plus 2 pi k. And secondly, where it's positive is going to be, let's see, SATC. So it's going to be in the first and the fourth quadrant here. So x equals, in the first quadrant, pi over 3 plus 2 pi k. And the other answer is going to be x equals, let's see, pi over 3 is the reference angle. Subtracted from 2 pi is going to be 5 pi over 3 plus 2 pi k. All of these are the answer. You don't have anything going on when you substitute it back in. So going on meaning that it's going to create an undefined answer. So you're looking at those answers as well as this one for all of them. Now, the easier type of question is if you have a specific interval. And let me just say, for time's sake, that when you have something like this, it becomes, you could make it easy or you could make it hard. Sometimes you have to square both sides, and if you did that, then it's going to create a hard problem. But the easy shortcut that you can do, because there aren't anything added on both sides, is you can create a tangent x by dividing both sides by cosine x. And when you do so, you get 1 equals tangent x by using the quotient rule. And that means that x can equal pi over 4, or it can also equal 5 pi over 4 in the third quadrant because it's positive. Sometimes you have to square both sides. If this were like +1, you'd have to square both sides. But when you do square both sides, you have to check your answers because it can produce extra answers called erroneous solutions. Let's factoring out a cosine x here. Radical 3 tangent x try that again. Radical 3 tangent x and minus, running as problems here, radical 3 tangent x minus 1 equals 0. Okay, cosine x can equal 0, or tangent x can equal 1 divided by square root of 3. If you solve both of those for 0. Cosine x equals 0 is going to occur at 2 answers. I'm thinking of this, and so it's this answer and this answer for my x, which means x can be pi over 2 or 3 pi over 2. And when I go to here, the question is, which quadrants am I looking at? It's the first and the fourth quadrant. And now the question is, what is the angle such that the tangent of the angle is equal to 1 over square root of 3? And that answer is going to be pi over 6 is the reference angle. And so my x in this case is going to equal, let's see, pi over 6. And pi plus pi over 6 is 7 pi over 6. Again, only looking at answers between including 0 to 2 pi not including. So that's going to give me those answers. If there's anything in the bottom, so for example, this one has a tangent x in it. Now, tangent x, I got to be careful here because tangent x here means that it's really sine x over cosine x. So if I have a cosine x in the bottom, then cosine x can never be 0. Because if it's equal to 0, it's going to be undefined here, which creates the original as undefined. That means that this whole side here is going to be eliminated. Because where cosine x equals 0, those cannot count. So be very careful. That's a hidden answer that does not count. And so looking at these, tangent x equals 1, you would, if you had, for example, cosine x equals 0 in this case, those would not work out as well. So just be careful when you're dealing with tangents and cotangents, secants and cosecants, to make sure that all of your answers don't produce a 0 in the denominator. Also be careful if you square both sides, you got to check all of those answers. These can be some time-consuming questions, and every little mistake will create a wrong answer, so be careful.